Okay, here we have, uh, okay, I have uploaded some sample for you. Okay, so as you can see, the first question may ask you that if you are given an EM wave, uh, determine the frequency, wavelength, and phase velocity of the wave. Okay, and at y is equal to amplitude, the amplitude of the wave was made to be 4. Find alpha. Okay, so maybe you are given a D and you are asked to find out the divergence. And then what does the divergence of the value means? Okay, so uh, we can look at the first question. The first question, so it's the traveling wave. Twenty pi y. Okay, the value is in volts. Remember, 2 pi f is equal to 4 pi into 10 raised power 9. So this will tell you frequency 2 into 10 raised power 9 hertz. Okay. Secondly, you have a 2 pi over lambda equals to 20 pi. So this value is 2 pi over lambda. Okay. So this will give you lambda 0.1 meter. Now the velocity is f lambda. So frequency is 2 to 10 raised power 9 times 0.1 and 2 into 10 raised power 8 meter per second. Now the B part is, uh, you should learn the formula A e raised power minus alpha x or y or t should be equals to the amplitude. Okay, remaining value. Okay, so the peak amplitude is phi e raised power minus alpha, and the question is at y equals to 2 meter. So you will put 2 here, and the amplitude is 4, right? So you can make a little correction. In solution, this value is also 2. Okay, please mark this is the correct solution. Okay, now you can find out the alpha here. Okay. This type of question we can set for exam as well as for midterm. Okay. Also, please look at uh, the class exercises plus the practice problem related to waves. Okay, so I also uploaded the practice problems, right? So you should also uh, this one. Okay, now this question is based on the same uh, formulas, but the concept can be a little bit tricky. For example, here, so you apply first formula, correct? You see, so it says that an electromagnetic wave traveling in a seawater was observed to has an amplitude of 98 volt per meter at a depth of 10 meter and an amplitude of 81 at a depth of 100 meter. So you are given data at 2 different locations. Okay, so first equation give you this one. At 10, it should be like a e raised power minus 10, amplitude is 98. If you want to solve equation 1, the data is not complete because the a is not given. Okay, but you are given another data point, 81.87 at 100 meter. So you put here. Now you have two equations, just divide them. A will be cancelled with A. Okay, so you can cancel it. And then you can solve here. Okay, so this is another way of solving the equation. Okay. Okay. Please do practice these type of questions. Okay. Okay. Next, uh, we have a vector field D. So, so D is e raised power minus 2y sine 2x plus y cos 2x. Okay. So how to find out the divergence? Okay. So remember, divergence is equal to the x derivative of dx. Now this is different. Dx is here plus y derivative of dy and z derivative of dz. Okay. So what is dx? Dx is this one. What is the because there are no z components, so it's 0. So, so what is the derivative of this with respect to x? Remember, e raised power minus 2y is constant with respect to x. And derivative of sine 2x is cos 2x multiplied by 2, because the derivative of 2x is 2, plus e raised power, sorry, plus cos 2x is constant, and derivative of e raised power 2y minus 2y e raised power minus 2y multiplied by minus 2. Again, take the derivative of minus 2y. Okay, so you would see that they are exactly same. So this and this will cancel out. The answer is 0. Okay. You see, sometimes the answers can be tricky. So what does this 0 means? So if I ask you to elaborate the answer, okay, how can you explain the answer? So the field is divergence less. That means that number of field line entering and leaving are same. Okay. This question we have already done during our class, right? This is directly taken from the class. So you see 15 marks. So can you solve this by using Maxwell's first equation? What is the Maxwell's first equation? We learned it today. Can you use this D and find out the volume charge density? Can you think about it? You can use the notes. Just open the first slide that we learned today. It's very simple. How to find out the volume charge density? Yes. Yes. Simple. Take the divergence. That's it. Yes. Del dot D is your answer. So we are given, so D is e raised power minus x sine y ax minus e raised power minus x cos y ay plus 2z az. Now you see the actually D is like this, e raised power minus x sine y, like this. Okay. So del dot D is equal to charge density. Del dot D is, take the x derivative. So x derivative, this is x. Okay. Sine y is constant, and derivative of e raised power minus x is minus x and minus 1, plus this is y. E raised power minus x is constant, cos y is sine y. 2 z, z is 1. Sine y e raised power minus x plus e raised power minus x sine y plus 2. Answer is 2. So we get charge density of 2. Okay, so this one we have already done. So Maxwell first equation is del dot D is equal to charge density. And also you can write D dot ds equals to charge. Okay, there are two statements. Next question is, describe the electric field as a function of electric potential. So what is electric field as a function of electric potential? Okay. Yes, yes. So if you know this, you can write few lines, you can get free marks. Free mark. So this value is here. Now this part B we haven't studied yet. Okay, maybe next lecture we will study this. So what is the value of electric field inside conductor? Okay, so this is not applied to you. Okay. For the following distribution of the electric V, sketch the corresponding distribution of E, vertical axis in volts and the horizontal axis in meters. Can you think about this one? What does it mean? If you know the voltage, take the derivative, multiply with the minus one, you get E. Right? This is gradient, right? It's a three dimension, right? X derivative, Y and Z derivative, correct? But this is only one dimension, so it's more easier. Just take the X derivative. Just take the X derivative. Yes, then take the X derivative and shift the curve on the Y-axis, multiply with the minus one. So if you are smart enough, you know what's the equation. This is find the slope, take the derivative. Here the derivative should be zero. Take the derivative, zero derivative, take the derivative. Formula is the X derivative, right? Let's do it. So start from 0, goes to 8, 3, 5, then 11, 13, 16, x, 30 and minus 30. Okay. That means first we take the derivative. So for this line, segment 1, the slope is 30 over 3, 10. So equation is V is equal to 10x. Right? It's very simple. So equation is 10x. So what is the derivative of 10x? 10. Correct? So what is E field? E field is minus 10. Okay. So when it goes here, you goes here up to 3. So part 2 is constant 30. Derivative of 30 is 0. Okay. Again, part 3, the slope is minus 10. And derivative is minus 10. And the electric field is plus 10. Again, this part is 0. And other part is again 10. Okay. So minus 10, plus 10, 3, 5, 8, 11. Okay. Okay, so after going to three questions, you have already received uh, 50 out of 60 marks. Okay. So question 4. There are three charges, 10 microcoulomb each, are located in free space at points with Cartesian coordinates. 3. Find the force on 20 microcoulomb charge located at this point. All distance are in meters. Okay. Can you model this question? We have solved this question before. Okay. So we can solve this question now. So there are three charges, 10 microcoulomb. Okay. And we are asked to find out the force on another charge, which is 20 microcoulomb. That's called the test charge, which is at 004. Okay, so the first step is to compute the position vectors. R1, from this point, we can say minus 3x. R2 is 3x. R3 is minus 3y. Okay, so R is given, R is 004, which is okay. So the first thing now is we'll find F1. due to charge Q and Q1. R minus R1 is, so you solve like this, Z4 minus 3x. Okay. Similarly, F2 is R minus R2. R minus R2 is Z4 minus 3x. First amplitude 4 square plus 3 square under root. Similarly, F3 R minus R3. So R minus R3, Z4 plus 3y. Okay, so you have three forces. The total force is add them together. Okay. Next question. A 15 nanocoulomb charge is at the origin in free space. Calculate V1 if the point is located at P1 is this. Now, do you know how to solve this? In tutorial, we solved the problem. Please listen carefully. Please listen carefully. In our tutorial, we solved the problem when you are given electric field, find the voltage. This problem is when you are given a charge, find the voltage. So there could be two types of problem that can be asked regarding the voltage, right? So how to find out the voltage when you are given a charge? So you see, charge is 15 nanocoulomb. This will be given. Okay, first, what's the point? The point is 2, -2, 3, and -1. So amplitude is 2 square, that's -2 square plus 3 square plus -1 square under root, and it should be under root 14. Okay, make sure that you take the minus inside, okay? Otherwise, the answer will be wrong. So we know that V is equal to formula. From formula, we know that V is equal to Q over 4 pi epsilon naught over R. That was the formula for finding the the voltage when a charge is given. Now the question says that calculate V1 if P1 is located at this and voltage is zero at this point. So actually there are 2 points, right? So we are actually looking for a voltage. P1 is given, and for second voltage also voltage and point is given. So we will use the formula V1 minus 0. That means difference of potential is equal to 15 nanocoulomb, microcoulomb, or nanocoulomb, sorry. 4 pi epsilon naught 1 over R. 1 over R is 1 over 14 minus. You can take into the bracket because everything else is same. What's the point? Other point. Other point is 6 square. This one. This one. Plus 5 square plus 4 square. The answer should be for B part. You see now the voltage is zero at infinity. For C part, the voltage is 5 at this point. So these are two important questions. First, given electric field, find the voltage. Second, given charge, find the voltage. Okay. So at this point, uh, we will be 3% like that. 3% like that. Okay. Then we be 5%. Next time I will see, I'll try to balance it. Four, four. This four. And trust me, maybe I'll. We can only trust you only. Okay, please listen. Uh, this is this is another sample for you. Okay. Okay. So you see, you've given a wave, right? It's already on the blackboard. You can see all the solutions are on the blackboard. So you see, you're given electric field, and for a traveling wave, find the direction, wave velocity, and wave amplitude, right? Okay, listen. We can also give you a question. Maybe if the frequency is this, a UP is this, and then construct the wave. Just put the values in the wave and construct it, right? It could be easier, you know. You don't need to solve it. Just do the question reverse. Okay. So don't expect that exactly the same question will be asked. Okay. Something like this. Yeah. At least alter something. Yeah. For example, if all these values are given, right, how to draw the wave, how to put the wave is almost same. Is almost. Yeah. So this question, you see, charge density is given. Okay, charge density is given, but it's hemisphere, right? That means that you can choose one limit into half. Okay, so it's 0 to pi by 2. Rather than 0 to pi, you can choose 0 to pi by 2. Okay, yeah. Now you see the integration is simple here. Okay, it's not difficult. Sorry. You see, we have discussed almost 10, 12 questions. So maybe this will not come. I'm not sure. I'm not sure. Yeah. Yeah. Previous solution also. You see, this question directly asked from the tutorial. Yeah. You are given a scalar field, find the directional derivative. So take the gradient, find the unit vector, multiply them. You see this one today, we also discussed this one and find the answer at certain point. Okay. So these solutions are already on the blackboard. Okay. Don't worry. So this one we have already done. Okay. It's a repeat. Okay. This question seems difficult, right? Because this was taken from exam during COVID days when students are allowed to solve at home, take home quiz. Yeah, yeah, but it's okay. Yeah. So you see the voltage is given. So voltage is again a scalar field. P naught over epsilon naught 1 minus e raised power minus alpha x, everything is constant. Okay. Find the electric field intensity. So what you have to do is just take the gradient. Okay. So we take the gradient. Just take the gradient. Okay. So because it's only has x variable, y and z are 0. So we only use x here, right? So 1 minus e raised power minus ax, take the derivative. Okay. So the derivative becomes, so this is constant, this is constant. This derivative is, one derivative is 0, this derivative is same, then power derivative is minus alpha. Okay. That's the only trick. So once you have E, then we say that, okay, if that's the epsilon flux density, find the flux density charge density. So D can be given by just multiply epsilon E, right? And just multiply this. Just two formulas. So actually the only thing we want the students to spend more time and get confused, right? Okay. Uh, I'm. Please listen carefully. I'm. I'm just writing down the uh, summary. Yeah. So maybe it will help you to prepare. Okay. So so for every question, maybe I can ask a very short question, simple short question. Okay. It's a kind of a free marks gift. Every question has one chocolate gift. Okay. So it could be like, what's E field, B field, what are the differences, right? So you can write many things, right? So B field, is due to the current flowing through the conductor. Okay. Yeah. So E field, just remember the basic differences. Electric field is due to the charges. It can be due to the charges at rest. It can be due to the charges in the flow. But B field is only due to the charges flowing, like a current, right? So when it flows, and E field is, we already know, is 1 over 4 pi epsilon naught Q over R square, right? And its direction is radially outward. B field is mu naught I over 2 pi R, and its direction is phi. Now you can write a whole story on these two formulas. B field is circular around the conductor, right? It is a function of 1 over R. It decreases linearly with R. E decreases 1 over R square. It follows inverse square law, right? So for B we use right hand rule, right? It's circular around the conductor. E field we discussed today is always perpendicular to the surface, right? So these type of questions. Then divergence, gradient, curl. I mean, what are the formulas? When we use them, what are their differences, right? So for gradient, we use on the scalar field to find the change, maximum change in certain direction. For divergence, we use to find out the flow, just like we use on the D field to find the flux density, right? The charge density. And for curl, we use it to find the circulation of any field, okay? For gradient, we use scalar, and then the answer is vector. For divergence, the input is vector field, the answer is just a number, scalar, right? It tells you whether the field is converging or diverging or is constant. Curls is applied on a vector field, and the answer is also vector, right? It tells you the circulation property, okay? And uh, further, let's say uh, Coulomb's law, Gauss law, divergence theorem, right? So these could be the short statements, okay? So what could be the main questions? For example, you are given a wave, right? Traveling wave. You can solve it for, let's say, UP frequency lambda, right? Or lossy medium, right? Yes, solve for UP F lambda, right? Direction, right? So do not forget the uh, the documents that I upload to the Blackboard, the practice problems, okay? You should know how to solve gradient and divergence, okay? Simply how apply divergence to solve and apply gradient to solve. You should know this. Then you should know that if you are given charges, location, I mean the points, right? Then how to find out the force, right? Similarly, given charges and location, how to find out electric field. So you should follow the lecture notes tutorial. Okay, you will find two questions. Okay, we solved yesterday. I mean, in the previous lecture. And so for divergence theorem, remember we solved that if you are given a electric field or D, right? So D dot ds plus so on. Remember F1 plus F2 plus F6. This question is actually equal to the volume integration of del dot d dv, right? Correct? This question, right? For example, if you are given d, right? If you choose del dot d, that would be charge density. Okay. Then take volume integration of this and you will get charge. This is important, okay? So you will be given a d, right? Just take the divergence and you will get charge density. Now take the volume integration, you will get the charge. Okay. Uniform infinite sheet. Okay. Okay. The midterm plus exam. If you do this, then you can 100% almost do midterm and 70% final exam. And yeah, yeah, just so if you count the number of questions, I guess it should be less than 25. Total number of questions so far what we have done, right? Including today's question, tutorial question. I think maximum the total number of questions is 25. So then you just review 10 about 10. Yes, including this. Oh, we just have time to review 10. So if you just cover these 25 and then again memorize the flow, given charge, given point, all find voltage, right? Just remember the flow. That's enough. That's enough. I'm afraid that all the class can get all kind of okay. Please remember, do not forget to mark. If you all get 100, how can I count the marks? You can go to the right. So whatever you all right? And then expect first. Right? And then so I say to you guys, let's say 25 maybe 5. And for every row, remember every time I give you a circle, this is important definition. Yes, maybe remember.
All the highlight remember and and then question review today like and our semester
That's what comes from my office. The page if you find anything
我嘅區服啦，揾多個你嚟啊！揾唔到啊，等你諗住等埋你一次。SP come here. Peter Jess.
Yes, of course. And they come, then the first word always say goes to the back. So I told them, if you want to sit from the back, sit from the front.
我影晒㗎，我陣間訂俾你。
哦，好啊，好啊，多謝你啊！佢影唔到啊，佢。首先啊。
哦，唔係咧，羅啲家姐又將堆嘢整埋計定。我都想，因為要食咁耐，佢就係睇清楚。I know that myself. I go to space. I thought they figured it out. I'm not done with beverages too. You know, quite nice. You feel the same. Yeah, I mean, most. Yes.而家就係解咗幾個先得 ，DIV 嗰個係，因為有時實在要我需要啲翻譯片。DIV 唔係單腳嘅。